November 12, 1942. German intelligence officer Oberst Wilhelm Canaris stared at the reconnaissance photographs spread across his mahogany desk in the Abwehr headquarters on Tierpitzufer, Berlin. His weathered face, marked by decades of naval service, creased with profound disbelief as he studied aerial images taken by a high-altitude Junkers Ju-290 reconnaissance aircraft over the Kaiser Permanente Metals shipyard in Richmond, California. The photographs told an impossible story. According to his most experienced analysts, including former Blohm & Voss shipyard engineers now serving in military intelligence, the Americans had somehow launched a complete 10,000-ton cargo vessel designated Liberty Ship SS Robert E. Peary in precisely 4 days, 15 hours, and 29 minutes. The previous week, intelligence reports indicated that Kaiser's Richmond No. 2 yard had produced another identical vessel in an equally impossible 10 days and 16 hours. Herr Oberst, said Captain Friedrich Wilhelm Birkner, Canaris's chief aide, pointing to detailed construction timeline charts prepared by German naval architects, our most efficient shipyards at Hamburg and Bremen require minimum 7 months for equivalent tonnage vessels. The metallurgical processes alone, welding, stress relief, quality control, cannot physically be compressed beyond certain thermodynamic limitations. Canaris nodded grimly, his mind struggling to process intelligence that violated every principle of naval construction he had absorbed during 32 years of military service. German shipbuilding represented centuries of refined craftsmanship, with vessels like the luxury liner Europa requiring over 2 years of meticulous construction. Yet these American photographs suggested industrial capabilities that seemed to mock the fundamental laws of metallurgy and marine engineering. If you're fascinated by how American industrial innovation changed the course of World War II, please subscribe to our channel and ring that notification bell. Like this video if you want to discover more incredible stories of engineering breakthroughs that shaped history. Share with fellow history enthusiasts who appreciate the remarkable achievements that won the war. Your support helps us bring these extraordinary stories to light. What German intelligence couldn't comprehend was that Henry John Kaiser, a California industrialist with no previous shipbuilding experience, had achieved something that established naval architects considered theoretically impossible. Kaiser's impossible trick represented the systematic application of automobile assembly line manufacturing techniques to naval construction, combined with revolutionary electric arc welding methods that completely eliminated traditional riveting processes. The breakthrough had emerged from desperate strategic necessity. By autumn 1941, Admiral Karl Dönitz's U-boat fleet was systematically destroying Allied merchant shipping at catastrophic rates. During the worst months of 1942, German submarines sank over 700,000 tons of Allied shipping monthly, equivalent to approximately 70 traditional cargo vessels. British Food Minister Lord Woolton privately warned Prime Minister Winston Churchill that the United Kingdom possessed only 6 weeks' worth of food reserves, while Soviet Premier Joseph Stalin desperately pleaded for increased American supply convoys through the Arctic route to Murmansk. Kaiser's solution required abandoning 4 centuries of shipbuilding tradition. Instead of constructing vessels sequentially from keel laying to final fitting out, the method employed since the Spanish Armada, Kaiser's revolutionary team developed modular prefabrication techniques that allowed simultaneous construction of major ship components in parallel assembly processes. The numbers spoke for themselves. Traditional shipbuilding required 230 days average construction time, employed 3,000 skilled craftsmen per vessel, and produced ships at rates insufficient to replace wartime losses. Kaiser's methods reduced construction time to 42 days average, utilized 15,000 semi-skilled workers across multiple simultaneous projects, and achieved production rates that transformed America into the world's dominant maritime power within 18 months. January 15, 1941. Henry John Kaiser stood ankle-deep in California mud at the construction site of his first Richmond shipyard, his steel-gray eyes surveying the skeletal framework of massive overhead cranes and concrete dry docks rising from the shores of San Francisco Bay. The 59-year-old industrialist possessed no formal naval architecture training and had never witnessed the launch of a single vessel, yet he carried something infinitely more valuable than traditional maritime experience: a revolutionary understanding of how mass production principles could transform any manufacturing process, regardless of complexity or historical precedent. Kaiser's extraordinary background had prepared him for this moment in ways that conventional shipbuilders couldn't appreciate. His construction company had built the Hoover Dam, completed sections of the San Francisco-Oakland Bay Bridge, and constructed hundreds of miles of highways across the American West. Each project had required innovative solutions to seemingly impossible engineering challenges, always completed ahead of schedule and under budget, through systematic application of industrial efficiency principles. The shipbuilding breakthrough emerged through Kaiser's partnership with Liberty ship designer George Gibson Sharp, a brilliant naval architect who had developed standardized cargo vessel plans for the U.S. Maritime Commission. Sharp's design called for 441-foot-long vessels displacing 14,500 tons, powered by reliable 12,500 horsepower triple-expansion steam engines, and capable of carrying 9,000 tons of military cargo at sustained speeds of 11 knots across any ocean. Kaiser's revolutionary insight involved treating shipbuilding like dam construction, as an assembly process rather than a craft tradition. While established shipyards like Newport News Shipbuilding Corporation and Bath Iron Works maintained traditional methods dating to the 19th century, Kaiser approached naval construction as a three-dimensional puzzle requiring standardized components, parallel processing, and systematic workflow optimization. The welding revolution proved absolutely critical. Traditional shipbuilding relied entirely on riveting, a labor-intensive process requiring teams of highly skilled craftsmen working in cramped, dangerous conditions inside ship hulls. Master riveters earned premium wages because their specialized skills required years of apprenticeship, and riveting mistakes could catastrophically weaken vessel structural integrity. Kaiser's chief metallurgist, Dr. Cyrus Osborne, developed all-welded hull construction using advanced electric arc welding techniques that were simultaneously faster, stronger, and required significantly fewer specialized workers. A single skilled welder could accomplish in 8 hours what traditional rivet gangs required 3 days to complete, while producing joints that were actually superior in strength and watertightness to conventional riveted construction. Margaret "Maggie" Higgins, one of thousands of women welders Kaiser recruited from automobile plants and electronics factories, later described the transformation. They taught us welding techniques in 2 weeks that took traditional shipyard workers years to master. The work was physically demanding. We often worked 10-hour shifts in cramped spaces with heavy protective equipment, but the pace was exhilarating. You could literally see progress every single day as massive ship sections took shape under our torches. Prefabrication became Kaiser's most dramatic innovation. Rather than assembling ships sequentially from bow to stern in traditional dry dock construction, his yards simultaneously constructed major hull sections, complete superstructures, engine rooms, and cargo holds in specialized climate-controlled assembly buildings. These enormous prefabricated modules, some weighing over 500 tons and requiring massive overhead cranes for movement, were then transported to final assembly areas for welding into complete vessels. March 28, 1943. Supervisor James Francis McCarthy checked his pocket watch as the 347-ton bow section of Liberty ship SS John W. Brown was precisely lowered into position at Baltimore's Bethlehem Fairfield shipyard, the intricate crane operation completing in exactly 43 minutes, a maneuver that would have required 3 full days using traditional sequential construction methods. The vessel, whose keel had been laid just 19 days earlier, would undergo sea trials within 1 week and enter active military service before month's end. The technical sophistication enabling this unprecedented speed represented a complete reimagining of naval construction principles. Kaiser's engineering teams, working with maritime commission designers, had achieved something shipbuilders considered impossible: absolute standardization of complex ocean-going vessels. Every Liberty ship measured precisely 441 feet 6 inches in length, 56 feet 10.75 inches in beam, and 37 feet 4 inches in depth, with identical steam propulsion systems, standardized cargo handling equipment, and interchangeable components that simplified both construction and maintenance across all 2,610 vessels ultimately produced. The prefabrication process reached extraordinary levels of sophistication that amazed traditional naval architects. Kaiser's Richmond No. 2 yard featured massive assembly buildings, each covering over 12 acres, where complete ship sections were constructed under controlled conditions, regardless of weather. Advanced flame-cutting machines, guided by precise templates, cut hull plates to tolerances measured in 1/16 of inches, while hydraulic presses bent steel components to exact curvatures specified in detailed engineering drawings. Revolutionary welding techniques transformed both speed and quality of construction. Electric arc welding, previously considered experimental for large-scale marine applications, allowed continuous seam joining that proved superior to riveted construction in both strength and watertightness. Skilled welders like Elizabeth Betty Loisel at Oregon Shipbuilding Corporation could complete structural seams exceeding 12 feet per hour, working with precision that consistently passed rigorous Navy inspection standards. The workforce transformation proved equally remarkable. Kaiser recruited workers from automobile manufacturing plants, construction sites, agricultural communities, and defense industries, training complete novices in specialized shipbuilding techniques within 3 to 6 weeks rather than the traditional multi-year apprenticeships. Women comprised approximately 30% of his total workforce, with many becoming expert welders, crane operators, and quality control inspectors in positions historically reserved exclusively for men. Inez Sauer, a former waitress who became a lead welder at Kaiser's Swan Island facility in Portland, Oregon, recalled the intense pace. "We worked around the clock in 3 8-hour shifts, with shipyard lights blazing all night long. Management posted daily progress charts showing exactly how many hull sections each team completed, celebrating production records with bonuses and recognition ceremonies. It felt like participating in the world's most important competition, racing against time to build the ships that would win the war." Quality control maintained uncompromising standards despite unprecedented construction speed. Each Liberty ship underwent comprehensive sea trials, including full-power engine testing, stress analysis of welded joints, water tightness verification, and complete systems testing before receiving Maritime Commission certification. The vessel's welded construction actually demonstrated superior durability compared to traditionally riveted ships, with fewer structural failures and better performance in severe Atlantic storm conditions. Captain Felix Riesenberg, Jr., a veteran merchant marine officer who commanded multiple Liberty ships during dangerous Atlantic convoy runs, testified to their exceptional reliability. These vessels handled 30-foot seas and enemy torpedo attacks better than many traditionally built ships, costing 3 times as much. The welded construction provided structural flexibility that riveted hulls simply couldn't match, and the standardized equipment meant that critical repair parts were available at virtually any Allied port worldwide. But what if Henry Kaiser's revolutionary shipbuilding methods had catastrophically failed? What if technical problems, insurmountable labor shortages, metallurgical complications, or simple industrial inertia had prevented the Liberty ship program from achieving its remarkable production rates? The alternative historical timeline reveals how perilously close the Allies came to potentially decisive logistical catastrophe that could have fundamentally altered the outcome of World War II. Consider the brutal mathematical reality confronting Allied planners during 1942's darkest months. Admiral Karl Dönitz's U-boat fleet was systematically destroying Allied merchant vessels at monthly rates approaching 700,000 tons during peak operational periods of the Battle of the Atlantic. In June 1942 alone, German submarines sank 144 Allied vessels, totaling 700,235 tons, equivalent to approximately 70 traditional cargo ships destroyed in 30 days. Traditional American shipbuilding capacity, operating at maximum pre-war efficiency levels with conventional construction methods, could have produced perhaps 180-200 Liberty ships annually under optimal conditions. This rate was mathematically insufficient to replace wartime shipping losses, much less support expanding military operations across multiple theaters requiring massive logistical support. Without Kaiser's production revolution, Allied shipping tonnage would have declined steadily throughout 1942 and 1943, creating supply crises that threatened military operations worldwide. Operation Torch, the critically important Allied invasion of North Africa, launched in November 1942, would have been completely impossible without adequate shipping capacity. The 107,000 American troops who successfully landed at Casablanca, Oran, and Algiers required approximately 850,000 tons of military equipment, vehicles, ammunition, fuel, medical supplies, and provisions transported across 3,000 miles of submarine-infested Atlantic waters. Traditional shipping availability would have limited this invasion force to perhaps 35,000 to 40,000 troops, completely inadequate for successful operations against experienced German Afrika Korps units, commanded by Field Marshal Erwin Rommel. The strategic implications cascade catastrophically through every subsequent major Allied operation. Detailed D-Day planning documents, archived at the Eisenhower Presidential Library, reveal that Operation Overlord required approximately 2.8 million tons of military supplies during the first 90 days following the Normandy invasion. Without Liberty ships providing massive cargo capacity, the cross-channel invasion would have been delayed until mid-1945 or abandoned entirely in favor of less ambitious Mediterranean operations offering minimal strategic impact. Soviet resistance on the crucial Eastern Front depended absolutely critically on American Lend-Lease supplies, transported by Liberty ships through treacherous Arctic convoys to Murmansk, Archangel, and other northern Soviet ports. Between 1941 and 1945, these convoys delivered 15,000 aircraft, 7,000 tanks, 350,000 trucks, 1.75 million tons of food, and countless other military supplies that enabled Soviet forces to halt German advances and eventually push Wehrmacht armies back to Berlin. Dr. Richard Overy's comprehensive analysis for the Imperial War Museum calculated the devastating impact of reduced shipping capacity. Limiting Liberty ship production to traditional construction rates would have extended World War II by an estimated 24 to 30 months. The Soviet Union would likely have been forced into separate peace negotiations by late 1943, while Japanese expansion throughout the Pacific would have continued largely unchecked until 1946 or 1947. The technological and economic consequences extend far beyond immediate military implications. Without proof that revolutionary mass production techniques could successfully transform heavy industrial processes, post-war American economic development would have proceeded significantly more slowly. The manufacturing innovations pioneered in Kaiser's shipyards directly influenced automobile production, aircraft construction, consumer electronics, and eventually computer manufacturing, industries that defined American economic supremacy throughout the Cold War period. December 7, 1945, exactly 4 years after the Japanese attack on Pearl Harbor that had thrust America into global warfare, the final Liberty ship, SS Albert M. Bow, majestically slid down the launching ways at Kaiser's Richmond Shipyard No. 2. The vessel represented far more than simply the 2,110th Liberty ship. It symbolized the culmination of the most extraordinary industrial achievement in human civilization, a manufacturing miracle that had literally built the logistical foundation for Allied victory across every theater of World War II. The final production statistics were nothing short of staggering. In less than 4 years of intensive construction, American shipyards had produced more total cargo capacity than had existed in the entire world merchant marine fleet before the war began. Liberty ships alone displaced over 38 million tons, equivalent to approximately 3,800 traditional pre-war cargo vessels. These remarkable vessels had transported an estimated 75% of all American military cargo during the war, delivering over 160 million tons of critical supplies to every Allied combat theater, from the frozen Arctic ports of Murmansk to the tropical harbors of Australia and New Guinea. Captain Arthur Wellington Moore, who commanded Liberty ship SS Jeremiah O'Brien during the historic D-Day invasion and subsequent supply operations along the Normandy coast, later reflected on their absolutely crucial strategic importance. Without these ships, there simply wouldn't have been any invasion of Europe, period. We carried absolutely everything required for military operations: Sherman tanks, artillery pieces, ammunition, aviation fuel, medical equipment, prefabricated harbor sections, even entire field hospitals. The success of Operation Overlord depended entirely on reliable cargo capacity that existed only because of Kaiser's production miracle and the incredible workers who built these vessels. The human achievement underlying this industrial triumph proved equally remarkable and inspiring. More than 1.5 million Americans worked directly in Liberty ship construction across dozens of shipyards, stretching from Maine to California, including hundreds of thousands of women who entered heavy industrial work for the first time in American history. Average construction time fell dramatically from the initial 230 days to just 42 days, with peak efficiency shipyards completing entire ocean-going vessels in fewer than 2 weeks under optimal conditions. The technological legacy of Kaiser's innovations proved permanently transformative for American industrial capability. Revolutionary welding techniques developed for Liberty ship construction became standard practice throughout heavy industry, while modular construction methods and parallel processing concepts directly influenced everything from aircraft manufacturing to modern automobile assembly lines. The fundamental principle of prefabrication became a cornerstone of efficient mass production, contributing significantly to post-war economic prosperity and technological advancement. Perhaps most profoundly, the Liberty ship program demonstrated conclusively that American industrial capacity could expand almost without theoretical limits when properly organized, adequately financed, and motivated by clear national purpose. This demonstrated capability became a fundamental cornerstone of Cold War strategy, proving that democratic societies could consistently outproduce authoritarian regimes through superior technological innovation, workforce flexibility, and industrial organization. Margaret Maggie Higgins, now 87 years old and living in Portland, Oregon, recently reflected on her wartime service as a welder at Kaiser's Swan Island shipyard. "We knew we were part of something absolutely historic. Every ship we completed meant American. Soldiers would have the supplies they needed, British civilians would receive food shipments, and Soviet forces could continue fighting. Those welding torches we operated 12 hours a day were our weapons against fascism, and we wielded them with tremendous pride and determination." Today, visiting the SS Jeremiah O'Brien, the last fully operational Liberty ship maintained as a floating museum at San Francisco's Fisherman's Wharf, provides tangible connection to this remarkable period when American industrial might literally carried Allied victory across the world's oceans. These sturdy vessels, constructed with revolutionary speed by ordinary workers under extraordinary wartime circumstances, represent enduring proof that innovation, determination, and mass production capabilities could triumph over any military force, regardless of initial advantages or traditional superiority. Henry Kaiser's impossible trick that had so confounded German intelligence became the foundation of modern industrial warfare, demonstrating that democratic ingenuity and manufacturing capacity represented weapons more powerful than any conventional military technology.